we go. So thank you for your attention, and I would like now to introduce the first speaker. He's Martin Russ. He's Managing Director, Austriatech. Austriatech was the coordinator of the INFRAMIX project. So Martin, whenever you're ready, I'm very happy to leave you the floor.
Martin, I think we cannot hear you.
You cannot hear me?
Now I can
now
hear
it
you.
works.
Now it works because I think I was unmuted. Now it works. Thank you. Good morning. Yeah. Austriatech was the coordinator of INFRAMIX. Martin Datler was the person behind the scenes. He's the caretaker also together with Anna-Rita today in the morning. So detailed questions, of course, are always possible. I will give you a short overview, a snapshot of what is INFRAMIX. So in a nutshell, we really worked on the, let's say, mixed traffic scenarios, more or less, for future automation and connectivity. We developed traffic control strategies, estimation algorithms, we developed digital and physical infrastructure elements to support the vehicles of the future. And we developed evaluation tools for really looking into new ways of evaluating the impacts on safety and efficiency mainly. So simulation on the microscopic and submicroscopic level, but then we also tested the scenarios in real world implementations and developed a kind of hybrid simulation approach. This led us to, I think, some major recommendations for future programs and projects. We developed an infrastructure classification scheme. We developed safety parameters. We developed a roadmap. And of course, we looked into the detailed exploitation plans of the developed solutions. So, of course, INFRAMIX is one of many infrastructure-related projects dealing with these kind of automation readiness, as we call it. All key platforms work on this future infrastructure perspective now. When we started the project 3 years ago and starting to develop it almost 4 to 5 years ago, I think we have been really overestimating how fast automation will come and also underestimating the role of infrastructure. Now, platforms like CEDAR, AirTrack, IRF, ASICAP, and also mainly, of course, on the European level, the CCAM platform is working on these future digital infrastructure perspective, on the physical and digital elements, on the data quality, on the maps, on the scenarios. So where do vehicles need what kind of guidance, on really the needed communication infrastructures, but also the legal requirements and digital road codes. And this goes more than to a future systems approach where we define in a common sense the roles of users, vehicles, and infrastructure of the future, also supporting new mobility services. So what we have done, amongst many others, we really have shown in very, very practical insights that infrastructure is really a key domain for even future research initiatives. But more than that, it's also what we worked out is what's next. So next should be, of course, more flexibility, and what we have seen, a link of our infrastructure support levels with the so-called operational design domains of a vehicle. Yeah? And also the question on which minimum elements we could combine to obtain the desired functionalities and support for the vehicles. It's going also in the direction that we see there's a wider perspective needed on the impacts. So not only on safety and efficiency, but also on environmental issues, on network effects, on service orientations. And of course, what are the related costs and benefits? So we did first insights on that, but I think this is really something for the next projects to come. And of course, also what we have done is first framing, so to say, of legal aspects, but there's more to come in respect of quality and trust of the services. And the user perspective is another thing that I think, yes, we did first trials, and the acceptance level of, and also the stated willingness to use the services provided by INFRAMIX was quite high. Almost, I think 90% of the people showed that they're, of course, this is a smart thing when it's dedicated. It's not, let's say, interfering with my driving, but it's really supporting me. Then I think this is a good guidance. But what kind of guidance can be presented in which way to the users is one of the next things. And last not least, collaboration is key, especially with OEMs. We had one in the project with BMW and service providers like TomTom, but there's more needed and more, let's say, alignment needed for supporting this kind of vehicle integration into the infrastructure. And with all that, we should not wait for the finish of the next research project, but we also, I think, showed a good way on how and where we can implement so-called no-regret measures starting by today. And with this, I hand over to the next panelist. Thank you. So,
thank you, Martin, for your presentation. And I would like right now to introduce Panagiotis Lytivis. He's senior researcher at ICCS, and he was also the technical manager of the INFRAMIX project.
So, good morning. I would like to share also my screen. Okay. So I hope you can see my screen, Anarita.
I can see your screen. Thank you.
Okay, perfect. So thank you very much for the kind introduction. As Anarita mentioned, I'm the technical manager of INFRAMIX, and I'm a senior researcher at ICCS. I would like to welcome you also today to this press conference. So I'm going to, in a nutshell, to present you all the technical developments of INFRAMIX. It was a really challenging task to fit them inside 5 slides because we have so many advances, so I had to leave some outside. I tried to make them more, let's say, comprehensive for the audience. So let me give you some brief introduction about what we did in the context of the project. So first of all, we tried to focus on the road infrastructure and how we can implement innovations at this side in order to support the gradual insertion of the automated vehicles in today's traffic. As we all expect, based on studies and recent researches, the initial introduction of automated cars is expected to disrupt a little bit the traffic in the beginning. So we need to focus, at least in the transition period, and this was the main goal of INFRAMIX, to maintain at least the same level of safety and efficiency as we have today. And in the medium or longer term, the target is to enhance safety, efficiency, and comfort. So these are let's say, the targets. So in the area of communication, roadside simulation, the product developed a lot of advances. So we were working with the latest communication standards, working together with standardization groups. Also, we had a big survey and study on the existing road infrastructure, road signs, what is needed in terms of coexistence of automated with conventional vehicles. And we proposed, in the case of one of the scenario we had, which was the lane dedicated to automated vehicles, we prepared also a sign, as you can see here to the slide. So this was proposed, and it was discussed by the road operators in consultation meetings and so on. Then in terms of simulation, we did a lot of work, because in simulations, in this kind of projects, we need simulations because we don't have so many equipped vehicles or automated vehicles, so it's a necessity. And we were working with different simulation tools and very advanced ones. So we had a co-simulation environment, coupling microscopic and submicroscopic simulation elements. Also, we deployed a hybrid testing in Austria, where we had an autonomous vehicle offered from virtual vehicle that was coupled with virtual traffic. in order to test some functions which are critical, and we need a safety testing environment using also the actual hardware. So we had a lot of work behind simulation. In the area of traffic control, we developed several, let's say, control strategies. Here I try to really highlight the most important ones. So of the findings. So first of all, the speed recommendation, we saw that they had a positive impact in terms of safety. The time gap adaptations controllers, they showed up to 50% increase in traffic efficiency compared to the scenarios where we don't apply any kind of control. We saw a small disruption when we used lane change recommendations. This, especially when we have the dense traffic, created underutilization of the road network, of the road capacity, and also created a little bit riskier traffic situation because of the weaving effects while asking, let's say, vehicles to change lanes. Also, we saw that applying a variable speed limit controller close to bottlenecks like on-ramps, off-ramps, tunnels, and so on, we saw that we have increased traffic efficiency by up to 14%, even if we have low penetration rate of connected automated vehicles. And the most important, let's say, outcome that is important for investors in the road infrastructure side is that we saw that when we are employing connected automated vehicle technologies, we don't need to invest a lot of money in the actual infrastructure. So we need less variable message signs, we need less spot sensors. This leads also to less maintenance costs and so on of the infrastructure. And based on our studies, let's say around 15 to 20% vehicles, if they are connected, then we can really minimize the amount of roadside sensors we need. Then another key finding of the project was the infrastructure classification scheme that also Martin mentioned in the beginning in his presentation. So I'm not going to go into detail into the scheme, but actually it's a classification of the infrastructure where Class C is what is we call today the conventional type of road infrastructure, while Class A is the most advanced one, providing all kind of digital information and guidance to the users. And this classification scheme, this taxonomy, as we mentioned it, it can really support and guide authorities and operators and investors to target what they need to go from Class C, Class D to Class C, B, or A in order to have more digital, let's say, features in their infrastructure. So it's a really important outcome. It's discussed a lot in several fora, in CEDR, in SICAM platform. And we are very proud of this, let's say, outcome. And the last part that I would like to highlight, all that we did, we wanted to check that all the users appreciated our developments. So we did a lot of base questionnaires. In total, we had 170 participants from all the IT stakeholders that participated in our workshops, in our demos. The key, let's say, outcome was that all of the involved partners, the majority of them, they thought that all our developments will bring positive effects, positive changes in terms of safety and efficiency in traffic. Although another issue we have to take into account is that they were not sure exactly how this will be implemented, the specific characteristics of this improvement. So they had a very good, let's say, idea that we're going to go the correct direction, but they could not mention the exact characteristics of this improvement. And also based on the 3 metrics we followed during this users acceptance, let's say, work, it was the behavior change, the willingness to use, and the perceived usability of all the technical implementations. And this was above 70% in all our, let's say, questionnaires. So this is all from my side. So thank you very much. And I would like to hand over to the next panelist.
Thank you so much, Panagiotis, for your presentation. And now I would like to introduce the third and last speaker, last but not least, Mr. Bernd Datler. He's Managing Director at Asfinag. So now, Bernd, you are the presenter, and I hope you can share your screen so we can see your presentation.
Okay, thank you very much. Good morning, everybody, and thank you for your interest. I also have a short presentation. Just try to share my screen. Can you see my screen?
I can see your screen, all right.
Okay, then let's go. I would like to bring a little bit to the table the perspective of us as a road operator. We were one of 2 road operators participating in the project, and we operate
Bernd, I'm sorry to step in.
Yeah.
It's just I can see your presentation mode, just for you to know in case you wanna.
Okay, so it's a little bit strange. So I will have to change. So now you should see the presentation as it is. Is that correct?
Yes. Much
Okay,
better.
thank you.
Thank you.
So we operate quite different types of highways, and of course also the challenges for automated vehicles will be very different on these highways. If you look at automated vehicles today, then they can only drive in their operational design domains automatically. So if you look at the diagram on the left, there you see on the y-axis, on the vertical, the different conditions, and on the x-axis different types of the network. And the automated vehicles only can drive automatically in certain situations that have been programmed and tested. And between those different parts of a stretch, you have to drive yourself. So if this operational design domain is left, then you have to drive yourself. And we want, of course, to minimize the situations where we don't.
Bernd, I'm sorry to step in again. I'm so sorry. It's just I can see some other windows on your screen. Maybe you can put them down. And also, I could see your GoToWebinar box. Okay, it was tapping covering your presentation. Now everything is fine. Thank you.
Okay, thank you. So what we want to do is to extend the operational design domains and to support it, as Panagiotis already pointed out, with infrastructure support. So if we can support the automated vehicles with additional information, then they can drive in more situations automatically, and we expect a positive impact on the traffic flow. And that's basically what this infrastructure support levels can do. So how could this work, for instance? I have a short video here. So now you see roadworks appearing on the left, and the cars need to merge into the right lane. So the cooperative infrastructure that is deployed on the VMS will inform the vehicles that they have to blend in, and also inform the automated vehicles on the right lane to have a certain gap with that the vehicles can merge into. This is only one little example where infrastructure can help to make the traffic flow more efficient, and that's what we want to achieve. So in INFRAMIX, basically we looked at 3 scenarios. One was the roadwork zones, as mentioned, with the road lane closure. Then a bottleneck, for instance, cars entering the network and having to merge into another lane, and then a dynamic lane assignment purely for automated vehicles. So these were the three scenarios investigated, and we had a couple of interesting findings, of course, there. So big success from our point of view is that the communication tests for cooperative systems were very successful. So we were able to send out not only the CITS messages for the day 1 use cases that already are production ready, but also first time in Europe the day 2 messages, for instance, as mentioned before, the gap advice, so how much distance is needed that other cars can merge into. And of course a couple of other messages and use cases. Then this infrastructure support for automated driving scheme was developed, and what we also did in Austria, that we also analyzed which portions of our network can support which of these levels. And the next step will be to look into what we need to do to adapt parts of our network to have a better support for automated driving even. Simulation was already mentioned by Panagiotis, was of course a highlight because this hybrid scenario, this hybrid testing looked onto the different situations with different testing methods, and so it is a very complete picture that we got there. And what we see, of course, is that we need control strategies to have a better traffic flow as the number of automated vehicles increases. And of course, CITS will be the core feature in these strategies. And we see that CITS will make a big difference in safety as well. What we will also do, of course, and what we also did is the testing of the CITS Day 1 use cases. Of course, they work. This is this roadworks warning. This is in-vehicle information, and of course, hazardous location information. And the first series vehicle, the Golf 8, also can benefit from this scenario. So what we will now do is that we will roll out cooperative technology in Austria. So we already deployed a couple of roadside units during the last years in the ECO-AT project, but also, of course, in C-roads. And we are in the final phase of a tender to procure even more of these CITS stations. And from next year on, we will equip roughly 500 roadside units in the next couple of years. So this will make a big difference in the support for automated vehicles in the future. So to sum it up, what INFRAMIX showed us is that we are on the right path, and that, of course, CITS is a big contributor to safe and efficient mixed mode traffic, and we are happy that also in INFRAMIX we could make the next step and benefit from the simulations and the testing. Thank you.
Okay, Bernd, many thanks for your presentation. It was very interesting. And also, I think you also opened the way, in a way, to the future, to the future work that's ahead of us. So I would like to thank all the three speakers. And now I will stop the recording and invite your questions. So invite the questions by the audience, especially from the journalists that join us today and media professionals in general. So as I was mentioning before, the questions will be handled by my colleague, Martin Datler. He was the coordinator of the INFRAMIX project. And again, if you would like your name and affiliation to be read aloud, please type your name and company in brackets after your question. Otherwise, you can just type your question and we will keep your name hidden.